I should have this thing should be fine. Let me check.
Yeah, I'm checking. So far, it's not
Yeah.
started. What a nice day today. Saturday morning. I'm not sleeping at 10 a.m. And why? Because of you, Alex.
Thanks. Oh,
Yeah, now we're
okay.
live, I suppose.
Yeah, we are live. Yay! And right
Awesome.
in time.
Yes, right in time. Technologists work. I suppose that's great.
How many people do we have live? Well, I know YouTube actually doesn't show it nicely,
No,
but
it does show. We have now some 2 viewers, and thanks that you're watching us.
yeah, shall we start, Igor?
Yeah, I suppose we shall start. So, hi everyone, that's our meetup number 2, right? So, today Alex is going to present his story, his project. It will be super fun. And we are X Technologists, and today we are again together with Andrew, who is slowly becoming a part of our team, and it's super awesome. So now we are 3, not 2.
Right.
And yeah, I suppose there is nothing more to say, so
Yeah.
I will give the floor to Alex. So welcome.
Yeah, thanks, Igor. Yeah, hi everyone. Hi, Igor. Hi, Andrew. I will give you a bit of time to introduce yourself in a minute. So indeed, today we introduce the PizzaScript. That's our second project. And there was we published an article this week, and actually it somehow duplicates this material, but not fully. So today is a live session, so it's some specific of a live session would be. Yeah, so this is the first part of this PizzaScript when we introduce what is this project, and not only I hope I will explain some of the theory of writing a new programming language, and also we will see some code today. So I don't know if some of you guys, Andrew or Igor, looking at the comments in YouTube, but if you have any questions, feel free to drop them, and we will answer them during the session, I guess,
Yeah,
or we'll try to
definitely.
answer them. Okay. Great. So yeah, our agenda today is it's not that big, but also not that small. So we hope we will finish in around an hour. So first, that's the part that currently is going on, is about us, introduction, and so on. Then I will go to the PizzaScript project, talk a bit about the goals and yeah, how it's structured, what's the point, and so on. A little bit of theory, like I said, what are the lectures, parsers, compilers, programs, and then finally the code overview, or we can name it as a merge request review. So I will go through all the code that is currently in our GitHub repository, and yeah, that completes the session for today.
Great introduction. So I might already have some questions, but I will keep it.
Okay. What question do you have about us?
Yeah, who we are and why are we here?
Yeah. Right. So let me introduce myself and a bit of our project. So yeah, X Technology. That's yeah. That we named it like that. It doesn't really matter. So
I think it does.
Okay. Yeah, so we are as enthusiasts in data science and programming ourselves, a group of 3 people trying to put these meetups and talking about some technologies that are, to be honest, quite new to us as well. So the main idea is that we try new technologies and approaches, and then share our experience with the audience, see the feedback, and move forward like that, both in our knowledge and in a technique that we show it. So yeah, trying to improve ourselves iteratively. Our goals are to learn new technologies, to share it with community, and listen for feedback from community, and of course build some projects and see the results, and check how it all goes. And best of all, to have fun. Like you see, Saturday morning, and we are on a recording, so that's fun, right?
For us, definitely.
And about me, just a few words. So I'm a software engineer for like a decade of years, something like that. And, my first language was JavaScript. Switching to Go and a bit of Java. Was having the last 3 years lots of experience with DevOps as well. So yeah, that's my background. Maybe Igor can also speak of himself.
Yeah, sure. So my name is Igor. I think I already said that. I'm currently a data scientist in the company Crayon. It's in Vienna, Austria. So the last 6 years, I think I was working as a data scientist. Before I was more as a data or business analyst. So also different kind of analysis. And yes, so I'm also running another project, which I would talk about in a couple of weeks. So please do follow us.
Which is Airbnb Analytics, right?
Yes, it's about data science, and we took Airbnb as our target or source of data.
Mm-hmm. Maybe now it's time to talk about Andrew a bit, right? He's our invited expert, yes.
Yeah.
Andrew.
Hello, guys. I live in Moscow. I work for several companies. Basically, I'm a kind of self-employed guy. So I do contracting to multiple companies, and I really like this way because you can touch actually different technologies during your regular day, and you can study all the day, which is very interesting. So I have one project in Moscow, one in London, and another in Norway. So that's it. Yeah, mostly I do DevOps stuff and some development on Node.js and Go language too.
Great.
All right. Cool. Let's move forward. That was the introduction part. So now let's talk a bit about this current setup, which is PizzaScript. So PizzaScript is our second project we want to talk about. That's my part and my turn. This is a new language, and as you can see, the greatest feature of it is its name. I think it's just great, and I hope you agree with me. But nevertheless, our goals for this project are to learn Golang, because this is still quite a new programming language for me to learn. Well, I know Andrew actually has already some experience with it, so hopefully today he can uncover some of the interesting topics of that as well as me. Me myself, I just started learning Go, so I hope that will help me. And the other part, which is also quite interesting, is actually to understand how programming languages and compilers work. That reminds me on something different. So I actually have a computer science degree, and we were studying this material in a university, and my experience after 10 or 12 years when I touched this topic. First time in 12 years, that was something really, really hard to remember, and it sounds like completely new material to me. But nevertheless, it's really, really interesting and deep learning stuff. So I'd like to go deeper and to touch a bit of a ground of this theory. Also, we'll show some of this today. And then the last of the goals for this project is, because we invented a new language basically, and one of the parts is to understand how different languages and how they work. But the target goal for this language is to be compiled into WebAssembly, so so it can be executed in any environment that supports WebAssembly, which is, for example, is our web browser or Chrome web browser. I'm not actually sure that all modern web browsers, I think Firefox does support WebAssembly, and all Chromium browsers do so. So yeah, all the main browsers should support WebAssembly, and then our language would be really successful to be executed on any of this environment. A little bit of the features that we planned for this language, beside the cool name, of course. I think JavaScript, since it's my background and it's actually quite easy to write language in, very convenient to start a new programming language with some of the basics of the languages that you already know. So that's for me JavaScript, and some generic and some generic syntaxes I will of course inherit from JavaScript, and it's also known as a C-like syntax of languages. So yeah, C or JavaScript doesn't really matter. And as all programming languages, PizzaScript also supports variables. And then what types of variables it will support? That's interesting and challenging already. So first, we will support everything that WebAssembly supports, and that's different kind of numbers, integers, floats of 32 and 64 bits. And one thing that WebAssembly doesn't support, but we still challenging ourselves to have in PizzaScript is string. So, but that's going to be a next stage, not today, but that's our goal at least. And of course, we aim to have different operations with the variables and these data types like concatenation or having mathematical operations with them. And actually, this part I will show today, but not with variables yet, but with numbers more. Functions, that would be nice to have, of course, functions. And since we say that we stand off on JavaScript, then probably will support closures. Not sure yet, but it just sounds so native and natural. So I'd like to have them. Dynamic types and coercions, definitely we'll go for that. The reason is because I suppose because I'm not yet in the stage of a project when I know that for sure, but I think that's going to be a really interesting challenge to write some compiler piece of code that supports these coercions, and I'm going to talk about that at some point. Interesting part is a standard library. So that's already super challenging, but I wanted to have some kind of support of standard functions in a language, and just to give you a hand, give you an example what that would mean. I actually have in some of these examples here this line of code which says experts IO print. So that's gonna be a part of my standard library. So that's some known functions that you can use inside your language if you expert them. And why I think that would be interesting is because actually you have to compile the standard library into WebAssembly, since WebAssembly works that it doesn't have any side effects on its own, right? So you cannot just print something in WebAssembly, if I remember correctly. You have to first import something into your module, import something like a printing function, and that's what we're gonna do. But we're also gonna write the standard library, and we're gonna write it, I think, in PizzaScript, but maybe not all of the standard functions will be in PizzaScript. Yeah, we will decide on that later. Just our goal for now is to have some standard library to be able to actually show some code is working. And I mentioned WebAssembly. That's one of the main goals. I myself spend quite a lot of time WebAssembly already, and that's a huge and a very deep topic to learn. And I still feel like I'm not quite specialist in this area. So that was also a point for me to understand this standard. And that's why we, as a last stage of our compilation of PizzaScript, is gonna be producing some code in WebAssembly formatted files. Well, WASM or WAT, that's two formats that WebAssembly declares that they actually easily transpiled one to another, so that doesn't matter which one we were gonna produce. WAT is more human readable format, so probably we'll start with that. But actually, we have a survey for you to help us decide what's going to be our next topic. So maybe even next time we can already show you how to generate modules to WebAssembly. But that's Igor, please.
Yeah, that's an awesome introduction. I just had so many questions, and I'm not sure how deep should I go. So maybe as I don't have the programming experience, would you please tell me a bit more about WebAssembly? So I heard about the assembly for the programming languages. So is WebAssembly something similar but for web?
Okay, that's a good one. So if we point in Google WebAssembly, that's the main page basically where we can find it. And so this is a standard which was declared, I think, in 2015. It was an agreement between all the browsers to that they will support some very low level language, or low level. We can name it language, I think. Which gonna be possible to run in all the browsers besides JavaScript, because JavaScript is still the main language in the web, and it will stay like that for a long time. So these browsers agreed to support some other format, and actually there were some attempts starting from 2010 and so on, but there were no agreement between browsers. So Chrome had some nice portable formats. I'm not sure if I will remember that. There's something with a portable in there. So basically, you could write some C++, C++ code and then transpile it. Well, not transpile it, but wrap it in some specific module that will be ported into Chrome and then execute it. So you could execute your C++ code in a browser already. But that was not handy, and the browsers didn't agree about that. So they started this initiative, WebAssembly. It was derived from Firefox project. Not sure if I remember that one as well. Doesn't matter really. So indeed, it's called assembly, and it's a very low-level format on how you can port your functions. And the idea is that you have so many libraries already written in C, C++, any other languages like Rust. I can go on, but there are like an infinite number of new languages. We just invented a new one, and then most of the most popular. The top of most popular languages, they already have this portability into WebAssembly, and that basically gives a very huge number of use cases where you can use it. Like I think one of the maybe most successful examples in WebAssembly is Google Earth project. So Google Earth, because it's it should be very performant as you look at it in the browser, and then you kind of try to process main information while zooming and zooming out the Earth and seeing different buildings and stuff like that. So that should be performant, and this project, I guess, achieved what it wanted, and to show that you can be performant and successful with just porting your C++ code to WebAssembly and showing it in a web browser. Yeah.
Cool. Yeah, great. Now I know much more than before.
Oh yeah, thanks. There is a nice, just last one example of. I like to show it. Actually, it's you can just type WebAssembly Microsoft Windows 95, and that's amazing. You can start a Windows 95 in your browser. That's really fun.
Back to
even more. You can start Windows 95, then open Internet Explorer 90. And look, it's amazing. I don't know if it doesn't work for me every time, but yeah, maybe
Can you share a link for that?
Yeah, interesting where I put that.
To the comments on
I will
YouTube. Oh, maybe later. Yeah.
The comments indeed.
Great, thank you.
Yeah. Eat my processor, I think.
Yeah.
Okay.
But I think we get the idea. Yeah.
Another question for you. Did you do some research or how you picked the Go language? Was you considered other common languages to start with to write this compiler?
Good one. Good one. Yeah, I have most experience with JavaScript. I think would be also a good choice to start a compiler. So for me was the first idea why I should pick Go, because I basically wanted to learn this language, and beside I have a link to show you. That's Thorsten Boll. And I just read it, and it says writing an interpreter in Go. So that was my most inspiring resource for this project. Yeah, like reasons why the Golang would be handy in this project. I think just based on the book that I read by this book, I think Go language can help a lot with not inventing the whole stack of the programming language that should work with programming language, like evaluation part. I'm talking about that thing. So you, for example, you parse your program into numbers, and then you have to evaluate numbers. So how you're gonna do that? You might want to implement your own abstraction on the whole mechanism, how you summarize numbers, for example, or you multiply numbers. But you can also use the environment of a language in which you write in an interpreter. And that's what this book shows. So you can evaluate some piece of a program just in Go, because you can understand expressions in Go, and then you can just write the code, produce a code from original language, which is a PizzaScript in our case, into the Go-like format. So you can use the internals of Go already without actually writing your processing environment, let's say like that. But that's actually gives me another idea of why would not I use this part from a Go language? Well, the idea of that just I explained was to compile it into WebAssembly, and then evaluation part completely happens on client side or in the browser or in Node.js, anywhere where WebAssembly is supported. So maybe we don't need that much this Go processing environment. However, yeah, the rest, which is learning Go, I still find very valuable for myself. So yeah, that's the main 2 points I have, I think.
Even I tried to learn Go.
So how do you feel learning Go after JavaScript? Is it similar or close or what?
Yeah, to be honest, I like Go. I especially like how you destructure your program in terms of just functions, and it's quite simple modules in that, so you don't have to invent classes or the inheritance tree for your classes, interfaces. I mean interfaces in OOP way. You still need to write interfaces in Go language, but yeah, that's okay. So yeah, I like how you destructure a program in Go. Indeed, like small functions that are doing the job. I like this low level of program that you write in Go. And yeah, I heard your point last time about the errors that you should return from functions, from methods in Go. To be honest, I didn't feel it yet like a pain point, but it might be in the future. I actually already in my main work, I experienced this problem already, that I have to propagate errors through return sentence. And I actually thought that I will find a workaround just by, I called it a logger workaround. So you introduce a logger, and basically if you encounter an error during the processing of a program, you just exit with the error code. that was my approach, and I got a lot of criticism from my colleagues, and I had to get back to the return and error flow. Yeah, but so far so good. I love I love Go, and yeah, I love some simplicity parts of Go.
Another question, if we still have time for that. Have you been touching some testing library and benchmarking? Basically, this part I love from Go after the JavaScript, that it's just part of the language. You can easily start writing tests and benchmark your code just with common tools inside. This is very easy and fast.
To be honest, I didn't try benchmark. That's indeed the interesting part. But I tried some standard Go functionality for testing. Right, you have a Go test, and then you can introduce flags like cover, for example, that will show nicely how much piece of code, how much lines of code are covered with testing, things like that. Yeah, it says 95.4% of state of the whole project, just a piece of yeah. So indeed, I like these built-in tools that you can already use just by having Go.
I think when you finish with your PizzaScript, it will be very handy for you to write actually benchmarking and see how lots of memory all this stuff consumes and how you can optimize that.
Okay, but the benchmarking is also built-in functionality of Go tooling.
Right.
Or...
Yeah.
Okay.
It's just the same way as testing. You just write another tooling.
Nice point. Okay. Yeah. I will put it in here.
Nice, a new point. Yeah.
Okay. But I think let's continue. Yeah. Yeah. Actually, I think we for now we are going right in time, but let's see. So PizzaScript, some examples. So that's my rough description of what PizzaScript can do, and I basically combined the ideas of having the worst programming language ever, and to combine it with different techniques that I find myself in other programming languages not that nice. I will show you some examples. So first, that's debatable, but I'll show you this example first. So that's just normal calculating expression in here, some numeric expression, right? Some piece of numbers. And I had an idea that, okay, why all the operators in all the programming languages have some priority? Why shouldn't we take all of them equally? And if you look at this expression in here, it's actually the result is 100, and in normal way it would be, of course, 55 in this case. But that's I haven't decided yet. I actually this part I implemented in a classic way, so it has priority in operands. But just a thought. I'm curious what you guys think. Would you write? Would you like to write some code in a language that does equal operators for you?
That's a nice question.
Not for finance.
No.
Probably not if it's something really important.
It's intuitively it's not that clear. I understand that. But I think having the braces, not the braces, how it's called again? Parentheses. Thanks. Parentheses actually clarifies the expression for you. But I mean, I'd like to try this idea maybe. But for now that I will, I will not implement it like that. So now they are not equal in the current implementation.
And for now. Yeah, sorry, just a question. So how easy it will be to create a new priority? So let's say the minus should go before plus.
Yeah, it's quite easy actually. Yeah, when all the classic examples they have this idea of priority, and basically the priority is is easy like that. So basically you say that's my priority. My priority array. So it says plus is before the multiply operation in here, and easier you can just do it like that, or even and that will work as well.
That's great.
Yeah, most implementations of compilers don't have problem with this. If you want to change an order, that's fine.
Yeah.
Okay. Next example I put in here. Of course, we want type coercions like we declared, and yeah, I mean, in mathematics, commutative property of operations should be considered as normal, but so not always happens in a programming languages like in JavaScript, for example. So this, I think that will work also in JavaScript. However, in JavaScript you have var, but you don't have val. So let's actually try to show what we will see in JavaScript. I will use my console in a browser for that. So let's declare two variables like that, and then I'll try to show what is gonna be this one. Yeah, it says it is gonna be 12, and then if I summarize it, vice versa is gonna be okay. So you see, it works a bit differently in here. It's still coerce these types to a string, not to a number, but JavaScript is quite complicated in that sense. It has a coercions that's about different coercions or transformations of variable type into some other variable type based on what operation is used between. So we gonna use a similar approach, but our rules will be slightly different, and that is just an example. If you start with a string, then the whole sentence will be treated as a string concatenation. Otherwise, we will try to summarize just numbers. Yeah, that's just a rough idea. Again, let's not put too many attention on that. Functions, and I found that in some languages there is a support for no return statement, and I really love that. So I want to embrace this as well. The idea is, and by the way, we like to declare functions just with a fun keyword. I mean, I think it's logical, right? Yeah, I like it here in this example. That's you don't have to say explicitly that you want to return. I mean, as I said, as I started with, our language will show not the best practices, but yeah, more like different kind of practices, let's say like that. Not maybe necessarily worst, but some of those are not the best. So in here, I don't use the return sentence, and still it actually returns a number. How do I know if I return a number? Well, that's a good question. I guess based on the arguments in here. So yeah, that's going to be a whole discussion at some point of how we coerce types, but not just yet. So no return statement. Kotlin variables operators. Yeah, I really can't explain how they chosen this name. I might need to read some articles, but in Kotlin, you have two different types of variables. In normal other languages, you also have that. So var and val in JavaScript syntax would be let and const, and I think in JavaScript it's more explicitly saying what it is. With a let, you can define a variable which can change the value of it, right? You say let a is 1, and then you can say a is actually 2, and that's fine. But then you have const which says b is 1, and then you cannot do something like that. That's not happening. And the Kotlin has the same, but with different operator names, var and val. So why I've chosen this example for PizzaScript as well is because I think the naming is really important, and you could choose better names in your operator. So again, I'm choosing this naming convention of Kotlin just to experience a bit this var and val confusion, let's say. But yeah, my point is not to say something bad about languages, just to find some interesting examples. Right, and then like we said, we are gonna compile it to WebAssembly, so we will support numbers from first place, but then we gonna also show something that is called hoisting, and hoisting is also highly inspired by the JavaScript language. That means basically that you can use the variable that is declared somewhere later. I'll show you in this example. Okay, I'll say console log unknown variable. Let's put it unknown. And normal case, it will be an error. But if your expression looks like that, then you will not have error anymore. And that's because all the variables that are declared with var in JavaScript are hoisted. So they are actually known to interpreter of JavaScript before the real declaration in code. And I think that's also considered as not best practice, because usually you should already have variables to operate with them normally. And in JavaScript, as you can see, that's not the case. And actually, in JavaScript, you have another example of hoisting, which is called function declaration. You also can declare a function somewhere like that, and then call it before the real execution happens, the real definition happens, like like that. So it should work. So yeah, that doesn't help with the visibility and the maintainability of code, but yeah, that's something. And I spent a lot of time with JavaScript. I really love this functionality, but it takes some more. You need to be more accurate with writing your code, and I guess it's not the best feature for people who are just coming to a new language, because they can do these mistakes because of not knowing them, not knowing the syntaxes and the semantics of a language yet. But for people who experienced all the pain during the years of programming, that's fine. Believe me. Yeah.
So as a small recap, you tried to collect all the ways how you could shoot yourself in the leg, and you want to implement it in your language.
That's a great one. Yeah. Thanks. Indeed, that's one of the main ideas. I will also post this link in later in YouTube. I really love this resource. It's unfortunately, I think it's from some time a while ago was written, and it doesn't have too much description what it is, but I think it's a study about languages in general. And this particular page has a really nice table comparing techniques of different languages, just grouped by what they do, like how the random is implemented in different languages, just syntactically. And I wanted to say it in a summary section, but I will shortly say it here. It's so much material about programming languages in the web. It's just very hard to get one pass of learning this material. It's a lot of reading and a lot of things happening for the programming languages. And this is just one example of a great resource that you can find in the web. But let me finalize. That was almost last piece of introduction, PizzaScript. So the last one, as I was saying about hoisting, actually I declare in PizzaScript manifest that hoisting is great. We will have hoisting everywhere, unless you actually declare that you don't want to have hoisting, and that's kind of the cool feature of PizzaScript. So you can configure how your compiler behaves. The different, yeah, it's also a known feature of programming languages, like TypeScript has it. Let me show you TypeScript compiler flags. So it has like a 30 or 50 flags that you specify how the sentences should be treated in the language, and in the PizzaScript it will be definitely the same. And how it helps, you might ask, why it actually would help you. So with TypeScript, it's quite a clear answer. Like the idea of TypeScript is that the improvement is this language is improvement for JavaScript, because it introduces types and therefore makes your program more sustainable and maintainable in the future. And the idea is that you would like to migrate your JavaScript into TypeScript, and these flags help you with making it iteratively. So you can start with just I will allow all my JavaScript to be together with TypeScript. That's fine. And then at some point, when you mature your code, you decide, okay, I'm ready to actually use just a TypeScript and then you just switch this flag. It's called allow.js, I think. And it says no longer JavaScript is possible in this project, so it will complain. Your compiler will complain if some JavaScript is found in the project. Yeah, that's my last speech for PizzaScript so far.
Last feature that you want to implement?
Yeah, let's go to implement. Let's not go to implementation yet. Let's talk about programming languages in general. Let's just a small introduction. We'll not go into details because of many reasons. First of all, it's a really huge topic, and I need a lot of time myself to better know it yet. But yeah, some of the basics we still need to have right now. So first, let's start with alphabet definition. Alphabet is quite simple. It's just all available symbols that your language or your alphabet can have. And there could be simple examples like 0 and 1. So you could have a language that contains just 0 and 1s, and then you can grow the semantics on top of that. So in normal programming languages, alphabet is basically everything that you can use, right? You can use Cyrillic emojis in your code, anything. And yeah, let's keep with the traditional way. Let's not limit ourselves. So we just gonna use a normal alphabet, which is let's start with English alphabet, but that doesn't matter in our implementation. Actually, we support as much as the Golang supports itself. So then we have an alphabet, which is all symbols, and then we have different texts written in this alphabet. So that could be any text that is composed from the symbols from the alphabet. And then, yeah, why this definition matters? It doesn't matter too much. But what matters is a set of chains that is allowed with this language. So if you are able to say to compose a set and say that this set completes my language, then yeah, that's your language. Like you could say my alphabet is 0 and 1s, and my language is 0 0 0 1 1 0 and 1 1. Basically, the representation of numbers in binary system up to two. How you call it? I forgot the word. Radixes. Doesn't matter. Yeah, radixes, I think it's called. So yeah, you just have to specify what texts, which text or chains, which set of chains belong to your language, and that's how you specify or language or even a programming language. Doesn't matter in that sense. And as you can imagine, most of the programming languages just doesn't have that possibility to have an infinite number of sentences written in the programming language. Basically, you can write anything. You can just start with declaring your variable and then declare the same variable 100 more times. In JavaScript, that's completely possible, by the way. I'll show you what I mean. So you have you can declare my A is 1. And then your sentence could be doing it 40 more times. And yeah, if you cannot just specify this set of variables finite in this case. And most programming languages also doesn't have that. So so yeah, our PizzaScript is gonna be also an infinite chains of alphabet programming language. I don't know how to sentence it probably, but yeah, that's an idea of programming languages that has an infinite possibilities to write a program. And then the question is, okay, but if you cannot declare all the chains, how you actually specify your language? And it seems that there are some studies that help you to define a language by, normally I would say, by defining an algorithm, how the programming language can be structured. And this algorithm in studies is expressed as grammars, and grammar is the next definition. So grammar is some simple algorithm in some language that expresses all the sentences in your language. I hope that's not confusing too much. So the most known of this algorithm form is called the Backus-Noir form, and those slides from the other link I will share with the audience later. This is just an example what the back noir form looks like. So you read it as left is something on the right, and the left is usually in studies is called non-terminal symbols, meaning that they not terminating the expression yet. And on the right is how can you interpret this symbol on the left, and you can have on the right side of this expression both non-terminal or terminal symbols. And I know that's a bit of confusion because I didn't define yet what is non-terminal, what is terminal. But believe me, it's not much more than that. Non-terminal can terminate expression, cannot terminate expression, and terminal can terminate expression. So you cannot have something on the left which is terminal, and you just cannot have this in a back noir form. Something on the left which is terminal, basically that defines, I think, non-terminal versus terminal. Yeah, that's so. Yeah, please, Igor.
Yeah, I think I became even smarter after the last 5 minutes. Yes. So
it's hard to believe, but
yeah, just to clarify a bit, when you're talking about left and right, what do you mean? I'm not sure if it's a stupid question or not.
The left is like before. Yeah, whatever operand you choose in between, you still have a left and right side. In the first in this image, you actually have a parenthesis, right? No, not parenthesis. I always forget this.
Colon.
Colon. Thanks. The colon as an operator between left and right, but in here you have like 2 colons and an equal sign, but that doesn't matter. So on the left, you say my expression. Oops. Back there. My expression is something that is operand, and operand is like that. And no, sorry. My expression is operand, and then you can have, I guess, this in this syntax. That means it can have an operand, and then theoretically it can have the sign plus, minus, multiply, or this one, and then the other parent. So you read it as your expression can be combined of other parts. And in here, operand, you see it's non-terminal because it also has a definition of itself. So we read it later in a second line as an operand can be a number plus minus an expression. So it's kind of a cycle here, or the recursive thingy. So it declares different concepts of this language by recursively referencing to each other. But at some point, you can see it in the next 2 lines in here, you say, okay, my operand is actually a number, and my choice while I'm writing the sentence in this language, I can say, yeah, my number, my operand is just a number here. It doesn't have any other expression. So, okay, what is a number? Number should be a digit, so it can contain multiple digits in there. And then you move to the last line, which is a digit can be only a set of these terminal symbols, and you cannot go from these symbols anywhere else. So that's where your algorithm basically stops. So that's how you produce languages, by referencing and recursively referencing to each other in this back noir form.
Yeah, now it's much more clear for me. Thanks.
Okay. Thanks, Igor, for questions as well. Yeah, I will not stop too much on that. I think that can go just go and go and go. That's let's actually ask you guys if you understand it better now. So yeah, what do you think is described in this form? What is written in here? You think what kind of language is written in that?
Do we have any A, B, C variants?
No, I don't. You have to compile it. Don't you have a Bacchus noir form compiler in your head? I thought everyone has, no?
Well, maybe I have, I just don't know it.
Okay. Maybe.
Maybe Andrew could help me here.
Yeah, I think it's kind of headache language. Yeah,
yeah, true. That's always true, by the way. But I think it's quite straightforward. However, so basically we see some terminal symbols, and just slightly looking at that, our terminal symbols are plus, minus, multiply, and then these digits in here. So I think And yeah, I'm also not an expert reading this expression, but it looks to me that it's just a calculator language expression here. So basically, with this language, you can put something like, let me open this guy. So something like that. I think that's what you can declare with this language. 3 + 2, then any like that, and that's basically it's gonna be our first example as well. So we are gonna show, and in the first pieces at least of this meetup of PizzaScript, we're gonna show how to build a calculator. And yeah, if you think this is complicated, I will show you the anti-LR repository, because this is the project which can generate the parsers from this backnoir form for you automatically. That's another way of how you make a compiler, sometimes a parser. Sometimes you make it manually, and some has a automatically generated parsers. Basically, both approaches have some benefits and drawbacks. So we're gonna stand with manual because we still want to learn how this all works. But yeah, I was going through this through this anti-LR project, which can generate these parsers from backnoir form automatically for you. But his slight more complicated definition. You can see, well, of course, it has some tangents and sinus definitions. Doesn't matter. So just to show you that it can be really not a simple one. Okay, next one. So what do you think is declared in here? And I will, and that's my question for Andrew and Igor as well. So just two examples of grammars are written in this kind of shape. I will read it for you, the definition in here. So we say that our non-terminal symbols, so left part of these expressions, consists of expression S. Now right, which is terminal, not always, but that the terminal symbols are zeros and ones. So we say that S can be presented as a 0 S1, and or S can be presented as 0 1. So that's basically a short way of declaring the language, or the language in backnoir form, even shorter than it was before. So what do you think is going to be a language produced by this grammar?
Well, I feel I'm still not too deep into this topic to answer this question.
Okay.
Some operations with binary.
That's fine. That's
numbers.
fine. You don't have to say something. That's it's just completely okay. And Andrew, I guess.
I think Andrew is muted.
I just the same as Igor. I was muted.
Okay. Anyways.
Yeah, so Alex has small connection issues, but I suppose he'll be back soon. And in the meantime, yeah, I'm really looking at this extended example and trying to understand what it represents. But to me, it's kind of not clear.
Can you hear
Alex? Me? Yeah, you're back. Welcome.
Sometimes happens, yeah. So I was saying that our language in this first one can be use chains of text like that, where every S can be on every iteration can be again 0 S1, or if at some point we decide to use the other rule, we can produce instead of S, we can produce 0 1, and that will terminate our expression basically. So our language is 0 repeated n times and then 1 repeated n times. So that's a language that is produced by its grammar. And in the second example, it's almost the same. It just, as you can see, it has a bit more rules, and how these rules are working. It says, okay, I'm gonna change my S to 0 S, and then I can do it multiple times, of course, right? I can just change in S for 0 S, 0 S, 0 S, but then at some point I change my my S to 0 A, and then it will be it can be some cycle in there, so I can on every iteration I can change my a non-terminal symbol into a in 1. So what I'm trying to say is that my second language in the second construction will be n times 0 and m times 1. So basically, that's going to be our language produced from second grammar. So yeah, that's a bit of theory, but I hope this exercise is looking nice.
Yes.
Okay. So yeah, that's the grammars. That's not yet the complete algorithm that can work on any machine. However, as I said, with tools like anti-LR, you can generate a compiler or a parser just by giving these kind of rules to this anti-LR project. And many automatically generated parsers work like that. But the other way of defining a language is to create a program. Compiler can be that answers one simple question: if this is a text of this language that we defined, an example could be a C++ compiler, right? That takes some text as an input, and then it does some series of checks. Can be a lexical check, syntactic check, semantic check, whatsoever. And first of all, it does many other things. But first of all, if it encounters a problem in your text, and in C++, you try to use some generic, I don't know, any other stupid sentence that doesn't belong to C++, then your C compiler will complain and will say, no, this is not a text written in C. Sorry. In that. So yeah, that way to define a language, just to write a program that answers a simple question: if this is text written in this programming language or not. So that's a program that sometimes is called a compiler. A compiler does that, and it does sometimes more than that. So let's describe a bit what the compiler does. Usually, compiler is a program that contains multiple steps, and basically it's up to you how you structure this compiler, because the only idea of compiler work is to basically say if the text is written in this programming language, and then do something else with that. It can do multiple things, but how you do the things is absolutely up to you. However, many science studies separate the steps how you write your compiler. And the first step in this program is a lexer. And basically what lexer does is takes the text of your original program and splits it into the meaningful lexems. And lexems basically is some types of data that you introduce for your language. So lexems can be variables, could be numbers, strings, could be operators. So anything that is that makes sense in your language is just lexems. So usually this is the first layer of a compiler, just taking the text and producing the stream. I already say stream here, a stream of lexems. And here's an example. Let's say we have this sentence, A plus B, and then call it with C. So our lexer will produce some lexems or tokens that are synonyms in here. And it says, okay, my first token is it specifies just a name here as a type. So it's a type name, and it has a value A. Second one is a type plus, and the value plus, and the name B, left parenthesis, then a name another, and right parenthesis. So basically, the first step is just to recognize symbols and produce tokens out of it. And maybe one point that is not covered with this example is that sometimes your symbols should be merged into one token. An example could be you have some phrase that specifies numbers, like I don't know, if you have a number with multiple digits, your lexem, produced lexem, should be containing the whole number. Not you don't want to produce lexem 1, then lexem 2, 3, and because that doesn't make sense, because you basically you still gonna need a step to merge this together, and usually this is done on the first stage. So you better do a merging part of tokens in a lexer. And then you have a parser. So parser works with the lexems from the first stage. So it takes this stream of tokens, and then it tries to understand if this is a program, again, is written in this programming language. So it applies all the rules known to a parser to understand if this is a language that we expect or not. And usually it produces some representation of a program to be sure that this is a program in this language particular. For that, you use another definition, abstract syntax tree. So basically, you have some hierarchical structure of different operators and of whatsoever happening in your program. So you build from this example, 7 plus 3 multiplied into 4. You build a tree which can be executed later on. Just going through this hierarchy, you say, okay, I have a plus, so I have to have a left operand, which is 7, and then a right operand, which is this is another sentence in here. So I first have to evaluate this one because it has more priority. So it's multiply 3 through 4, and then you summarize it all together. So yeah, that's AST, abstract syntax tree. It it's representing declaratively your program, and every language written in any programming any program written in any language can be represented in some kind of this tree. And actually, I have a link here, which is found very nice myself. So this is an example. You can choose any language that you'd like to parse into the AST. I don't know many languages myself. Let's take I don't know, JavaScript. So JavaScript, you can choose a language that you want to parse, and you can choose the representation, the IST representation of it in here. I know Acorn and Babel from JavaScript world, so let's choose Acorn. That's fine. And then I will just put a simple sentence like that: 1 plus 2, and we see the representation in here. It says, okay, the top level is a program, and the program contains a statement. A statement is a binary expression, and the left operand is yeah, I'm trying to find it. Start end. Should be 1 and 2, right? Let me search in here 1. I don't see 1. Okay, so this representation in here, I guess, this Acorn representation, instead of yeah, I should have 1.
Was it the position?
Yeah, it looks like it's a position, but I think, okay, that explains it. Yeah, I should just expand it. So indeed, it has a left operand with value 1 and the right operand with value 2, and the name of operand is should be also written somewhere. Yeah, operator is plus. So yeah, easy like that. And then you can, if you put something more complicated, like I don't know, var array is actually array like that. So it's gonna be you see this is growing. So it says I have an array expression in here, and it has elements representation in there, and each one of them has a value, and it has a reference indeed to the point in the original program where it's written into. So yeah, that's the IST tree. It's just representation, declarative representation of your program. And then the question is this IST a standard? And yeah, not really. Well, it's kind of standard to have an IST, but the format of IST differs from implementation to implementation, and you can declare your own IST definitions types. That's absolutely fine. And we're gonna do the same. We're gonna just introduce our own parts of IST. It shouldn't be any standard for that, because in our case it's gonna be simple in a calculator example. And then the whole picture again. So we have a program, we split it into tokens, and then we parse it, we generate an IST. IST can look like that. So it has top expressions, and it has different hierarchy of expressions. And then you evaluate this tree somehow. That's the last step that I put in here. So the last step can be a compiler, evaluator, you name it, interpreter, anyways. So the idea is that you traverse this tree and you evaluate it in the right order, in the order of the priority of expressions. And basically, you already generate a tree in knowing the order of operators and knowing how it should be. And that yeah, in the last part, you just go through this tree and evaluate it on the fly. It can be evaluation, so producing the result, but it also can be just saying yes or no, is that a program written in a programming language or not? Or it can be producing some low-level low-level code, like in assembly or in WebAssembly, like PizzaScript is aiming for. So imagine we have an AST from original program, then we iterate, and we generate some other text sentences, but nowadays written in a WebAssembly format, in a WAT. The only thing, it's a great website with great documentation. However, it has some drawbacks. It has a lots of reading material, which is I don't know. It's more than War and Peace by Tolstoy. Yeah. So and sometimes it's not that handy to find information about here. So what I was trying to show, the WAT format of WebAssembly. So what we're gonna do, I think, WebAssembly. Let me show you somewhere. Yeah, as expressions, blah blah blah. Yeah, something like that. So simple expressions like that we're gonna generate. So yeah, declaring a function, declaring a module. This is a declaration in WAT format of a function. So we gonna iterate over our tree and produce this small modulus definition in WAT format. Right. An hour passed, and we almost. Igor?
Yeah, I actually have two questions. Maybe you partly answered some of them. So you've been talking about that the first step is a lexer, then the parser, and then a val. And so which one of them is taking care of understanding whether this is the language you want or not? Because you said that first we want to understand if this is the elements which might be in the language, and only then we could work with them. Or lexer does lexems, any lexems.
Yeah, good question. So basically, at any point of your compiler, you can say, no, this is not a program in this language. So if you encounter some symbol from the alphabet that you don't support, you can already throw an error saying, yeah, this is not supported, or you can skip it. That's up to your implementation. And with Parser, it's kind of the same. So if you encounter like A++ B, then it's up to your parser to decide what you're going to do with that. Either you support this unary plus operator, so the not unary, probably is the wrong word. So the operator that can be applied from the left to right. So the plus can be applied to a number in a normal mathematical notation, but you can, as an author of language, can decide if that is a expression that is supported by language. So in your parser stage, you can also say, no, that's not supported, sorry. And this is also a part of decision that your compiler does. So everywhere, that's a small answer.
Okay, yeah, I get it. And also another question about this AST tree, or ICE tree, how I should call it. You build it, so the parser builds it, and then evaluator traverses it, right, in a way that it wants, because there are multiple ways how to traverse the tree, right? So it's the feature of the evaluator, how to process it.
It is. I think the point is that you already have a priority when you generated the tree. So no matter how you traverse a tree, I think so. I actually I need to check it afterwards. It's a question that I don't know yet for sure, but I had it myself. So I think when you generate this tree, you already take a point into the priority, and then while you're traversing, it doesn't really matter how you traverse it, because your priority is already there. So in here, you cannot plus the multiply sign, right? You already know that this is operand, and then you have to evaluate this first anyways. It doesn't matter on which levels that happens. So your tree already represents the right order. Well, I hope that that is somehow clearer clears it. But I agree that is important.
I think it makes sense.
Yeah.
Thanks.
Okay. Right. So time for code review. Code code review. I will not spend too much time on that, but first about technology. So Golang, as we already explained, we're gonna use a Go for that. And then I had this idea of using reactive operations, reactive operators, or ReactiveX, and I haven't talked about that yet. Yeah, so I had this idea that you can decompose your program in terms of these reactive streams. So the ReactiveX is a reactive streams implementation. Basically, it's a way how you operate with data in your application. You treat all data as an asynchronous flow. So everything that comes to your program and that traverses your program somehow is a data, and then you can see this data as asynchronous pieces of data that just flow in through different operators or different functions. So that's a high-level idea. And then this ReactiveX sort of declares circumstances in which you can do that. So you have some definitions. You have subject, you have object, subject. I might be wrong in terminology, but I think subject is something for you for that you can subscribe for events. Object is something that can subscribe that can generate events. Yeah, again, I can mistake in here. That doesn't really matter, but that you produce some events, some program produce events. It does it asynchronously, and some other parts of your program can subscribe to these events. And since it also does it asynchronously, it just can consume them as soon as they are triggered, and that's therefore you basically don't have that much binded in your program. The only binding point for all the actors in your program is this subscription to different events. So after you subscribed, your function as an autonomous part of your program can somehow operate with this data, produce different other events, can also map them, reduce them, and that points to another part of this ReactiveX implementation or definition, is something that is called operators. So that's the most important part, I guess, of this standard. I'm not sure. I think it's not going to be visible like that. It's better to choose a full mode. So in here, you have multiple operators defined. It's, I think, about 100 of them. So the idea is that, like we said, you have this data flow in some parts, and you can subscribe to these data flows. You can trigger your own events, and these operators help you to combine this asynchronous data in any way you want it. So basically, you can skip some parts of data. You can filter some parts of data. You can map into another types of data inside your application. And yeah, as you doing it separately and independently in each part of processing this data, then your program stays loosely coupled, and the only common way is to subscribe for these events, subscribe for these data flows, and produce new data flows. Yeah, I hope I intrigued you at least. Maybe not clarified it yet, but intrigued. And I had the idea of decomposing the program into these reactive flows and reactive operators. And I tried it once, but this time I tried it with Golang and with ReactiveX implementation of it, which is RxGo. So I hope later in future events we will actually understand if that was a good approach to choose this technology, or maybe that was not suitable enough. Could be some benefit points in this ReactiveX approach. So why we choose ReactiveX? Why would it help us? And I put just one in here for now. That's the only one I could explain it for myself. So with ReactiveX, you have this standard in there already. So you have the idea of operators, you have the idea of subscribers, of objects, of subjects. So you don't have to invent it in your application itself. Otherwise, you have to invent a contract in the program, like, okay, that's gonna produce something. I need to know in which collection it will produce, so then I need to combine it somehow. So yeah, my idea was to use reactive instead of that. So you have reactive X, which already declares collections. It already has a declared interface for that, and your way of writing a program is just to choosing the operators and the choosing what you emit as a part of your program. Yeah, that's kind of it about reactive X introduction. Yeah, that's what our program should output. That's a rough example. So we put 1 + 2, and it should recognize, the lecture should recognize that the first one was the number 1, then the operator plus, and then the number 2, and then again the same. Yeah, that I think that shows one of my attempts to use operator debounce distinct until changed. So you see, it's the same input but the other output. That's interesting. That didn't allow me to use this operator distinct until changed. Oops. Come on, 1 second. Okay. Right. So yeah, lecture. That was what I want to produce in the first part, right? So I have let's talk about what I have right now. So we put it into repository. You can find it on our X-Technology GitHub, X-Technology. And it's a project in Go. Of course, it has a main Go, which then just calls a function of REPL subpackage. Yeah, it has a dependency of the RxGo. Some I see, yeah, Prometheus, something I didn't expect actually to see that much dependencies in here. I was expecting only of RxGo, so maybe I will need to clean it. So yeah, I need to check if I actually need these YAML dependencies, for example. Doesn't look so. So the only dependency I was expecting is to have an RxGo in here. That's a way how you declare the dependencies in Go. And you also have this sum file that has a hash sums of your dependencies. So you can be sure that you use the same dependencies as the other colleagues of your project. And yeah, main Go, quite a simple one. And then you have a REPL, and the REPL is a very normal thing for programming languages to have. So in Node.js, for example, you have a REPL like that, so you can have an interactive interface with the user, then where you can define some programs, small sentences in a program language that you've chosen. In our case, it's JavaScript. So there A is 1 that will be interpreted somehow, console log 1, console log A. And then, yeah, the REPL is a read, evaluate, print loop. So it listens for user input and then outputs the evaluation of this input. So our REPL is it's kind of a small one. It doesn't have that much. It has the default libraries to use, the scanner to use, the buffer scanner to read the user input, and then what it does in here. You see, I have actually created the parser and eval already, but I'm gonna talk about it next time. So instead of that, I'm gonna produce what the lecture does. So let me put it like that: FMT, and then L tokens, I think, like that. Yeah, to be honest, I have to clean a lot for the next time for this project, but the idea was to have something working, and the calculator was the first example to have here. So I create a lecture instance in here, lecture new, and I put the input into that, and then a lecture should split it into the tokens and produce tokens. So let's see if that still works. Run it with go run main Go. Yeah, it outputs this sentence from main Go. And to be honest, this first part, I think the main Go, REPL Go, I almost copied from this writing an interpreter book. But yeah, the rest with RxGo was written from scratch here. So yeah, it says this hello world, and then I can put some expressions here. 1 plus 2. Well, I guess what happens here is it doesn't nicely outputs my tokens yet. So let's actually have a look what the tokens function look like. Okay, tokens. I need to call print, I think. Yeah, the tokens does the whole thing, and then I should be able to print it to output it somehow. And I thought I actually have the print method here, but oh yeah, I have it. Okay, I have a print in here. Let's do that. L.print. Okay, 1 plus 2. Yeah, I think works. Yeah. So what we do here? We put some input. Let's put a big number in here. So yeah, it should also merge these numbers into the one if that is what our compiler thinks should happen. And then okay, let's have a look at how this all works. So we have we create a lexer. We have a small function lexer, and I took the original implementation from the book, and I tried to use streams instead of that. So this function was an original one that is not used anymore. The most important is of course this tokens function. So that does all the work. So let's have a look. I create an observable, and I generate all the tokens, all the symbols from this input at first. So I can use this RxGo just operator. Let's have a look quickly what the just does. So the just operator is kind of known as a producer operator. This one produces events. So you can see in this example we use off. Off is also a producing operator. Is almost like that. So we say that we produce just one item in here, and just I think it does it from multiple ones. So convert a set of objects into an observable that emits that of those objects. That's how it does it, and it's quite common that you draw these marble diagrams for your observables. This pattern is called observable, reactive X or observable. So you show it like that. So you have something, and then you produce a stream of this something. It can be one something, or it can be multiple something. So if you put one, then you trigger just one asynchronous event with a one value. If you have a multiple objects to produce, so it will be produced different data asynchronously. Yeah, and that's what we do. So we produce for each symbol in our input, we produce the event with this data. Then I flat map it. Now, actually, what happens here, and please never mind what I said before. So I produce the whole text in here, and then I use a flat map operator. That's another one to split it actually by symbol. So let's go in here. Let's have a look at the flat map operator. So I produce the whole text, and then for each I split this into the symbols, and I produce each item separately by using the just operator. And the flat map, what it does, it can convert an observable and flat it to the mainstream. So that's what I do here. I basically convert a set of observables into just one observable from the first stage. And the output of this observable, which I save as a part of my structure in here, it contains just every symbol. So this observable contains every symbol from the input in here. Then I just create this finalized creation of this instance, and then let's go to the tokens. That I think gonna complete this part. So the tokens basically process the input, which is already split into symbols, and I had to do many tricks with that. So since I'm using these asynchronous operators, it is the hardest part in this approach for me by now is that you cannot use recursion normally. In many cases, when you're writing this compiler things, you just call call recursively different other functions, and that's basically also how the Backus Noir form works, right? You have a reference, recursive reference to another operator, and that's not fully compliant with how reactive streams supposed to work. I think at least. And that's the most difficult part of this implementation for me right now. So how to basically make this recursive calls just by iterating over this stream of asynchronous events. So that part is the most difficult, as I said. But let's have a look. So I iterate over the observable. I do some trick here to put the last event, which is meaningless, but that's just for implementation details. So now I have each symbol be produced as asynchronously. Then I do a small trick, which is that's kind of clear. What I do here, I say, okay, if my current symbol is a white space or whatever, or maybe tab symbol or new end of line or new line, I just keep it. That's how I filter these symbols from the original text. Let me actually go into here and show you the filter diagram of Marble. So it just takes like that the whole set of symbols passing, and then it filters by some function, by some decision function. And our decision function is quite simple. It's just here. It says, yeah, first I convert a symbol to a string, something to a string, because in observable you don't, because I know that's a string in my implementation. And then I say if it's something like space or tab symbol or end of line, I will just keep that. So I will filter my original source into the meaningful symbols only. So that's kind of easy. And then the second part, that is the recursion that I was saying before. So that's the part that took me the most effort for here. So what I need to do is to go through this stream of data, right? And I need to decide at each point that, okay, if it's a number, and if my previous symbol was a number, I should merge it. And normally it's going to be just the iteration over the array, and I will save the previous value somewhere, and then I will grow this value if that having sense. Like if for example I go through digits, right? I just concatenate digits into the strings and so on until I meet some other operator, and yeah, there is no very easy way to look ahead in these observable streams because they just events passing for you asynchronously. So how I had to do that, and I was considering actually the reduce function, but problem with reduce function is that it produces only one value. So the reduce, and basically a reduce function is something that I also know from JavaScript. It can iterate over all the values produced asynchronously, and then it summarize it somehow into just one result. So that would help us, and I think it will help us in the parser part. But unfortunately, it's not what will help us with the lexer, where we have to merge on the fly some symbols into tokens and still produce them as a multiple instances. So how I managed to do that? Reduce doesn't help because it produces just one value. What I tried to use first, because you have this possibility, it's called a distinct until changed. So that would be nice if that actually worked, because that's what it's supposed to do. Distinct until changed. It says I'd like to continue this. It's hard to explain without a diagram in here, but it says it will skip symbols until some decision function returns true. So if we have a number and digits as a stream, and then we have an operator plus, for example, and then again digits, right? Then we can say first I will iterate over just numbers, because they don't differ in our understanding, right? They should belong all to just one token. And then you have plus, and then you will do the other iteration basically, and then you will get to the third iteration, because there's going to be again digit, and the digit differs from operator. And that would work, and actually it almost worked for me. I have a piece of that in this example. Yeah, that was my naive implementation on that, right? So what I'm doing here, I say, yeah, I'd like to take the current digit or current symbol, and I'm gonna just answer a simple question here. If this is a number, then I will need to save it somewhere, and I think I didn't show it in this particular case, but I will save this character in some current saving running value. That's not what happened. So what the problem I experienced in here is that it's completely asynchronous in this case, and you cannot control which part of your data flow will be executed next. So yeah, I'll try to show it in here. With the same input, you have a different flow of output. That was the most difficult part to understand why and where. But yeah, I think the idea of this distinct until changed is that this part happens correctly, and the next flowing and any time. So it doesn't, the way how you save it or cache this value, it just will not work with this asynchronous nature of streams. Yeah, I know this part is a bit complicated, and that also complicated to explain without showing. So let's go to the real implementation. It's almost concludes our topic today. So I was here, and where I stopped was a scan operator. So the scan is it's kind of a reduced thingy, but the beauty part of a scan operator is that it collects the data from a previous iteration of all the data that was consumed before. So let's find the operation in here. It has this marble diagram. So yeah, that's like a reduce, but a reduce for every step, and that what allows us to make some kind of analysis of what data has been before, and what depending on what token I take right now, what is my current token, I can pass. I can generate the correct data for the future operation. So that's that I took as an implementation in here, and it looks just like that. So I introduced some intermediate token. I can name it like intermediate type, and basically what it says, something that is gonna be returned, and the return is the real value, and something to be saved. And to be saved is not, I'm not sure if that's a real value or not, because on this iteration, I don't have enough information to say if that's going to be the final value of this merging function or not. And yeah, it looks like that. So if I'm having a number of a current one of a current element, and if my previous element was a number, I will just save it in here. I will save it in a current intermediate expression or token. Otherwise, if I got something that is maybe a number, but previous was not a number, or maybe now it's not a number and previously it was a number, now it's time for me to return. I say I will return the previous value, and I will save the current value. So that's easy like that. So I basically filter and map at the same time, and then yeah, that makes the algorithm work for us. And then the only thing is left is basically to filter non-returned values yet. So the values that are that should have some return value, I filter, and then I map it to my final representation. So I say, okay, my token currently has return, which is the correct one, and then I decide on type of my token. I say, okay, if it's an operator, then my token type would be operator. That's yeah, the last two parts I think quite clear. Yeah, that's an algorithm. It's maybe it took me a lot of time to explain it, but that part was not that hard. Actually, the next part, which is gonna be next time, yeah, actually, that's doubtable, but debatable. But we're gonna see. Next part is gonna be a parser, anyways, at some point, and the parser takes it to another level. So in the parser, I need to indeed to produce some hierarchical structure, like we said, and I still have to use these reactive patterns. So I need to still iterate these asynchronous portions of data, and I'm doing it kind of linearly. And I cannot use recursion in there because I don't have functions to be called. I don't control my asynchronous data flow, and that's what was tricky in this implementation. But it works actually. It works, and let me show you the final state just as a pitch for the next time. So let me revert this part. I think we'll revert it all. So as I said, current implementation has both parser, lexer, and the evaluation without WebAssembly yet, but that's for the next time. So now, if I have this compiler of PizzaScript, I will just say 1 + 2 is going to be 3, and then I say something minus something. That also works. It looks like it works actually. And then I even can multiply things. That also works. And the more complicated work, I hope. Let's say it works. Yeah, that's isn't it cool, huh?
It is. It's a very nice algorithm you came up with.
Thanks, Igor.
RxGo. Yeah.
All right. Yeah, so that was a long discussion, 1.5 hours. So let me briefly say what's going to be next steps. And actually, my next step is going to be ask you guys what should I focus for the next time. I made this small survey. I will also post it in our YouTube. So yeah, if you think I should focus on implementing more PizzaScript in my compiler, there's gonna be option for that. Or if I want to go into more parsers and clean my current implementation, look more into these asynchronous operators and what is the best to use there, and yeah, what's other point of parsers. So there is option for that. And there is a third option to go into the WebAssembly, which I also would like to have. But yeah, basically you choose where I should focus next time. And if you have other proposals, that's also fine. Maybe I should shut up as for the next session. That's also good. Change all these reactive collections. Yeah, I have some to-dos myself, so I'm gonna clean a few pieces of code that I showed you has some to-dos. And I want to write some tests for my parts of this compiler. So I started already with a lexer tests, and I've also done one for my parser part. But yeah, that's still far from ideal. So I'm gonna work on that. Wanna indeed do this maybe in benchmarking and so on and so forth. Yeah, so that's a bit summary. So yeah, we've done the first implementation of naive calculator, lexer, and parser, as you saw, and parser I will explain next time probably, and the evaluator. Yeah, the next one is a use-appropriate tool. So I'm still not sure if that wasn't a good idea to use these observables. Yeah, it seems logical that you have the input text, and you can basically split it into the reactive streams of data. But then, yeah, I got this problem with finding an algorithm how to write a lexer or a parser without recursive calls. And I think I made it, but yeah, I'm still not sure if that's going to be a very big problem to expand it. But we're going to see, I guess. Yeah, learn Go. And as I said, there is so many material about writing your own language, and the compilers. It's very hard to keep it on track. So what helped me is this there's a nice resource for language studies. I already showed you this one, so that's going to be my inspiration for PizzaScript. And then I found, I think just yesterday, found these nice links from 20s as well. That's even better in here. So yeah, as I said, there's so many material, and it's so beautiful. It's like you can go to any of this article. It just nicely shows you differences between these old cool languages and why they were built like that and how they were built. So yeah, it's tremendous how many material are there. But of course, I found like a modern material about and the courses on how to make your own parser. Like this one by Dmitry Soshnikov, I definitely recommend. I think it's on Udemy. You have to pay for that, but some of the lections are free on YouTube as advertisement for this course. So yeah, as usual, Dmitry Soshnikov is a great. He's great. Greatly explains this material. I knew him from I think from JavaScript world. He was explaining ECMAScript parts like 10 years ago. Was my favorite readings there. So nice to see that he continues and continues with different topic. Definitely would recommend this book that I already showed, Writing Interpreter in Go. Just for general knowledge in the interpreters and compilers, that gives a great first step to read about. That's not that long read, and it's actually quite funny and nice. So yeah, it explains algorithms very, very well. And some just two articles that I by writing I learned Parser. So this one by Jonathan Apodaca, sorry for pronouncing it maybe wrong. That was my successful article. Basically, that what I stopped at, and that where I tried to implement a parser, and that what gave me the last hand of doing that. Before that, I was completely lost. Like, okay, what shall I do? And yeah, there is, of course, much more interesting material. So I will send all the links with addition to this YouTube video. Yeah, right. Was a bit
That's a lot of food to process.
Yeah, sorry for taking so much time. Andrew is still there.
Yeah, Andrew is still here. No,
I
you
completely
don't have to
enjoyed
sorry.
it.
Yeah, I also enjoyed it.
Yeah. That's great.
Yeah, thanks.
Yeah,
Andrew.
I also really liked it. So many links to go to, and basically I have my weekends ahead.
but I think for your next talk, I need to take a PhD first to understand you completely. I would say it was quite difficult to load in my head.
Thanks, man. I still need to learn, right, how to make it more simple to understand. So yeah, that's our part of craftsmanship. But please answer this survey. What should we focus next in this PizzaScript journey? And Andrew, question for you maybe. So will we have a session 27th February?
Sorry, will we?
We will have a session with you 27th of February. You wanted to speak about your project, right?
Yeah, correct.
Okay. What's going to be the project?
Well, it will be some kind of practice of doing of DevOps stuff. So basically, how you can apply DevOps techniques into your existing or new project. So these DevOps techniques will allow you to easily, build, test, and deploy your project into the real world, so other people can see it on some particular domain. So I'm gonna speak about that. So basically, I'm doing this project for myself, as I have multiple ideas. In each idea, I need to somehow to deploy it and help people to collaborate it. So that's basically the thing which will help you to do that.
All right.
Sounds great.
Thanks.
Sounds
Looking
great,
forward. Yeah, and we're gonna announce it, I guess, in next week. We'll create a session and YouTube event for that, right? So please follow us and follow our channels, which are Telegram, Twitter, whatever. What you find the best for you? And Medium, yeah, indeed, Medium, and we have actually nice articles in there already. One by Igor, one about PizzaScript as well, and about Airbnb projects. So check out Medium, and yeah, looking forward.
Great, yeah. Thanks everyone for joining and for watching it later.
Yeah, thank you. Good night.
Have a nice weekend. Bye.